Hello and welcome back to STEM and Society Unplugged. Today we will be diving into electron and molecular geometry. Electron geometry is the arrangement of all electron groups, both bonding and lone pairs, around a central atom of a molecule. Molecular geometry, on the other hand, only describes the arrangement of the bonding electrons to the central atom of the molecule. An example of a type of molecule would be CO2. As you can see here, CO2, it's written as CO2, but the formula is O-CO-O. C here would be the central atom. The C is the central atom of the molecule. So the electron and molecular geometry would be focusing on the electrons around this element. Now, these geometries are as follows: linear, trigonal planar, tetrahedral, trigonal pyramidal, and bent. Linear is when we see no lone pairs around the central atom, but two bonded pairs around the central atom. Trigonal planar is when we have three bonding pairs and zero lone pairs. Trigonal pyramidal is when we have three bonded pairs and one lone pair. Tetrahedral is when we see four bonded but no lone pairs. And bent is when we have two lone pairs and two bonded. Now, to see these illustrated in a way, we have this here. This would describe our linear geometry. Linear geometry is when we have X, let's just say that's our central element, and we have two elements right on either side of it. So this would be our linear geometry. Next, we have our trigonal pyramidal geometry. Trigonal planar. Trigonal planar looks like this. It's on a flat plane, and X again is our central atom, and we have an element here, we have an element here, and we have an element here. They're all about 120 degrees spaced out. Next, we have our tetrahedral geometry, and again, these first three geometries are when there are zero lone pairs. And electron and molecular geometry will always be the same when there are zero lone pairs. If there's zero lone pairs, your electron geometry is your molecular geometry, and your molecular geometry is your electron geometry. Drawing your tetrahedral, it's a little bit more involved. It's not as simple as just drawing lines and whatever. Again, X signifies our central atom. We have element over here. We have an element over here. But then this is where it gets different. This is just illustration. We have this here. If someone asks you to draw the structural formula of a tetrahedral geometry, this is how you do it. And then we have this here. We shade this in, and that's our last element, our last atom in the molecule. And these are going to have less than 109.5 degrees. Next, we finally get into our geometries in which there are one lone pair. There's one lone pair around the central atom. And this is are trigonal planar. Oh, trigonal pyramidal, my apologies. Trigonal pyramidal is when we have 3 bonded and 1 lone pair. And that could be, and this is illustrated as X, our central atom, Y, our other element. Then we have another element here, and then we have our third element here. But instead of drawing our 4th element as we did with tetrahedral, we draw 2 lone pairs. This is our lone pair of lone pair of electrons around the central atom of X. And X can be any element. It all comes down to how the structural geometry, the structural formula goes. Now lastly, we have our bent geometry. Bent geometry is when there are 2 bonded around the central atom. However, we have 2 lone pairs as well. Now, following other patterns, it is a little different how we draw this in. When we get there, I'll explain how you have to be careful with drawing a bent molecule. We have X, our central atom. We have our Y element. Then we have, but here, as you could probably guess, we draw 2 lone pairs here and here. These are our 2 lone pairs. But be careful when drawing bent geometries, is that you have to make sure that when you're drawing it, you don't bring out it too you don't bring it out too horizontally. Make sure you focus on pointing it down on a downward slope. And that's all. That's a little preview into molecular and electron geometry. Make sure to like and subscribe.